Well, hi, this is Bob, and we're getting ready to take a look at section 3.6, which is graphing linear inequalities in two variables. And what we're going to do here is we're going to have the same type of equations in x and y that we had earlier in chapter 3. And we're going to be graphing them somewhat like we did before, but now after we draw the graph, we have to decide to shade, or on which side of the graph to shade to represent the inequality that they've given us. I'm kind of looking over on page 199 at example 1. And I think we can pretty much summarize everything we need on this particular problem here. Notice that they've asked us to draw the graph of x plus y is less than or equal to 4. Well, the only type of graph that we've come close to on this so far would be x plus y equals 4. And it turns out that we actually use x plus y equal 4 to help us with the graph of x plus y is less than or equal to 4. Remember now, this would be called an equality because of the equal sign, and because we have an arrow in the x plus y less than or equal to 4, that makes it an inequality. Okay. I think the first thing to look at, excuse me, the first thing to look at is we have actually 3 different ways that we could draw this particular graph here. And when I say this particular graph, I mean the graph of x plus y equals 4. They actually give us some steps, and they tell us that the first thing that we should do is do the graph of the equality. And we could use, I think what they probably used, or the easiest way for us, would be to use the 0, 0 method. In other words, gave us the intercepts. And if x is equal to 0, y equals 4. And if y equals 0, x would equal 4. Now, one thing you'll notice as you follow along in the this little talk here is they don't actually spend time showing you how they got the graph. They show us what to do after we have the graph in terms of shading. And so the graph of x plus y equals 4 would have the x and y intercepts of 0, 4, and 4, 0. Now, we have 2 things to decide now. The first thing we need to decide is there is a line that goes through 0, 4, and 4, 0, and we want to know whether that line is going to be a solid line or a dashed line. And I can summarize that right now. Whenever we're dealing with an inequality, if it's a less than or equal to or a greater than or equal to, the line is solid. Okay, and as we'll see, if we have a greater than or a less than, the line is dashed. And when the line is dashed, it means the boundary line itself is not included in the solution set. But I'd like to remind everybody again that x plus y less than or equal to 4 is going to be solid, okay? A solid line. So we draw a solid line through 0, 4, and 4, 0. Now, the last thing we need to do, and you can look over on the top of page 200 and show how they graph this, but here's the method they give us to determine which side of the graph the shading goes on. Remember, the line that I just drew takes this coordinate axis and divides it in half. We've got some, or it divides it into 2 regions, I'll say. We've got a region above the line and a region below the line, and now we have to choose which region to shade, because on inequalities, remember, on a number line we shaded the line, and now we're going to be shading the plane here, the coordinate axis system or plane. So let's take this original inequality of x plus y less than or equal to 4. Now, you can choose any point that you like, but when the origin is open, it's the easiest one to plug in. Remember, the coordinate of the origin is 0, 0. So what we do is we plug in x for 0, or 0 for x and 0 for y, and see if it makes a true statement. In other words, is 0 plus 0 less than or equal to 4, which would be like saying 0 is less than or equal to 4. And since that's a true statement, that means that 0, 0 is on the same side of the graph, or on the same side of the, well, that's the correct way to say it. It's on the same side of the graph as the shading. In other words, we have to decide whether to shade above the line or below the line, and since 0, 0 satisfied the inequality, then we will shade on the same side that contains 0, 0. Now, you can either physically shade with the edge of a pencil, or you can just draw some hash marks like I've done there. Okay, and then the last point I wanted to make, and I'll just draw the graph up on the top of the next screen here. And we know this is a graph of, oops, I gave it to it this way, x plus y less than or equal to 4. The other significant thing to keep in mind here is not only is 0, 0 satisfy that equation, but this whole side of the graph that I've just circled everywhere here is composed of an infinite number of points, and of course each point that we choose represents an xy coordinate. And if you were to plug the x and y coordinate into the inequality that we just graphed, when you add the x and y together, they would be less than 4. Just say, for example, that this point right here was minus 3, 0. Well, that point is on the side of the graph, the side of the inequality of this graph, so I'll plug in minus 3 and 0. And sure enough, minus 3 and 0, or minus 3, is less than or equal to 4. So that's the graphical, or another graphical significance of the inequality. Okay, well, let's take a look. Well, I guess we can look at their rules here. I tried to follow their rules on this example. On page 200, they tell us to graph the solution set for a linear inequality in 2 variables, which means the xy axes. We're supposed to replace the inequality sign with the equal sign. So for example, if we have a less than or equal, we replace with an equal sign. Okay, then we graph the boundary line using one of our 3 methods to draw a graph. Okay, we can plug 3 points in, or we can use the xy intercepts, or we can use this y equals mx plus b. But whatever we do, whichever method we choose, we go ahead and graph it as, or determine the points by using an equal sign. Okay, once we've determined the points that are going to be on the graph, before we hook those points up with a line, we have to decide whether the line is going to be solid or broken. And that's pretty straightforward. If we have a greater than or equal or less than or equal, the line will be solid. And if we just have a less than or a greater than, the line will be dashed. And again, the significance of a solid line means that the boundary line is included. Any ordered pair on the boundary line would be an answer or satisfy the inequality. And if the boundary line is dashed, that means it's not included in the solution set. In other words, we're not allowed to plug those points in to the inequality. Okay. Well, let's take a look at example 2. We're supposed to graph the solution set of y less than 2x minus 3. Okay, well, according to the book, we're supposed to go y equals 2x minus 3. By the way, I think I'm going to give you a little hint right now here. If you haven't caught it already, this boundary line will be dashed because we have a less than there. Whenever we have a less than or a greater than, the line is dashed. So, but we treat it as y equals 2x minus 3. Maybe I'll just choose a couple of real simple points. If I'm going to use this method, I'll use 0, 1, and 2. Although I could also use the point slope method here because the y-intercept is -3 and the slope is 2 or 2 over 1. But I'll use this method that they showed us earlier, but I'll do it in my mind. If x is 0, y is -3. If x is 1, y is -1. And if x is 2, y is +1. So I'll go find those points. There's 0, -3, and 1, -1, and 2, 1. Okay, now I've got my points, and I've got to make my decision as to the whether it's a solid or a dashed line through the points. And as I said before, since it's a less than, it's going to be a dashed line. Okay, then the last thing we need to do is determine whether the graph is above the line or below the line. Okay, so we take the y less than 2x minus 3 and we plug the origin in. It's vacant, okay, so I can plug the coordinate of the origin in because that's a simple one to plug in, and we end up with 0 less than 2 times 0 minus 3, which is saying 0 less than -3. Now, if when we plug the origin in it makes a true statement, then we graph on the same side as the origin. When we plug the origin in and it does not make a true statement, then that side of the graph, that region does not represent a solution set, and the only other place it can be would be on the other side of the line. So since 0, 0 did not give us a true statement, in other words, 0 is not less than -3, then the only place the graph could be would be on the other side of the line, which I've just shown there. And of course, you can look on the top of page 201 for that also. Okay, how about example 3, 2x plus 3y less than or equal to 6. Okay, well, I think I'll use, okay, this is our inequality. And by the way, I've already made my decision that that's going to be a solid line because it's a less than or equal to. Whenever it's a less than or equal to or greater than or equal to, the line that we graph is going to be solid. So then I replace the inequality sign with an equality sign. Then I can go to work. I'm going to use the intercept method here. Be a lot easier than getting y by itself and plugging in some points, except I'll kind of do it in my head. When x is 0, then y would be 2, and when y is 0, x would be 3. So 0, 2 I say is there, and 3, 0 is there on my graph. And remember, I said the line is going to be a solid line. I determined that ahead of time. And now the last thing we need to do is, where does the shading go, or the crosshatching, as it's also called sometimes. Does it go above that line I just drew, or does it go below the line? Well, the origin is open, so I take its coordinate and I'm going to plug that into our inequality. By the way, if the origin isn't open, then you've got to find another point. But if you're doing these on graph paper as requested, that should not be hard. Anyway, let's see. Is 2 times 0 plus 3 times 0 less than or equal to 6? And that would be saying that 0 is less than or equal to 6, and that is a true statement. So since 0, 0 satisfied the inequality, then everything on the same side of that line that we drew would satisfy the inequality. And we'll finish off like that. Okay, well, what we haven't done yet, and I'll do this right now, would be to show what happens. It's no more complicated. It's actually a little bit simpler, but example 4 says draw the graph of x less than or equal to 5. Well, we know that this is going to be a solid line because it's a less than or equal to. And hopefully you recall that all graphs of x are vertical. So what I've just shown there is the graph of x equals 5, but it's also going to remain solid, of course, because the inequality is less than or equal to 5. Now, which side of that line are numbers for x less than 5? Well, they're on to the left of it, so it would look like this. So there is a graph of x less than or equal to 5. Now, just so we have another example, let's say somebody gave us y greater than 2. Well, any graph of y is parallel to the x-axis, and it's flat, as we said, or with slope of 0. And I've got to do something before I start graphing here. I've got to make the decision whether the line is solid or dashed. And since it's a greater than, it's going to be dashed. Just a little harder to do with this pen here, but the line is dashed. And then I have to ask myself, well, where does the graph go? Does it go up above that line or below? And the numbers below the line get smaller as we go vertically down, so and the numbers get bigger than 2 as we go up. So of course the graph would have to be above the line, and that would be the graph of y greater than 2. Well, that's the presentation there. Let's go do a few homework examples, or a few homework problems, and I think that'll do it for this section. This section is important, though, not only for the new material, but we also get a review of graphing that we've seen in the in the recent sections. How about question 4? This is over on page 202. 2x plus y greater than 4. Okay, graph by any method you like. Keep in mind that this is going to be a dashed line. Here's their first step. Write it as an equality. I'll use the intercept method here. If x is 0, then y would be 4. And if y is 0, x would be 2. So we have 0, 4, and 2, 0, and we knew that it's going to be a dashed line. Okay, well now we're going to take the coordinate of the origin and plug it into 2x plus y greater than 4. If it makes a true statement, then the graph will be on the same side as the origin or below the line. If it does not make a true statement, the graph goes above the line. So what we're basically asking is 0 greater than 4. And 0 is not greater than 4, so it must be on the other side or above the line. Remember, if 0, 0 satisfies, then the graph is on the same side as the 0, 0. If it doesn't satisfy, then it's on the other side of the line. Well, let's take a look at question number 12 first. X minus 5y greater than 5. Okay, I know immediately the line is dashed. So according to the book, we go x minus 5y equals 5. I like that intercept method. We'll use that again here. Okay, if x is 0, we get minus 5y equals 5, or y equals minus 1. If y were 0, then we'd get x equals 5. So 0 minus 1 and 5, 0, and then a dashed line. Now we need to decide if the graph is above that dashed line or below that dashed line. So I take the coordinate of the origin, 0, 0, and plug it in to x minus 5y greater than 5. And what we're basically dealing with then is 0 bigger than 5. Okay, 0 is not bigger than 5, so 0, 0 doesn't work. That means everything on the same side of that line as 0, 0 won't work. So the only other place the line can be, or excuse me, the graphing can be, the shading, if you will be below the line. Okay, I also wanted to do question 24. And 24 asks y less than 1/3 x plus 3. And I think what I'm going to do on this one is go ahead and use the method that they gave us. I would like to remind you that you could graph this. It has a y-intercept of 3, 0, 3 if you will, and a slope of 1/3. So we could use this with methods that we recently learned. But I think I'm just going to let x equal 0 and find out what y is. Then I'll let x equal 3 and find out what y is. If x is 0, this is what I'm doing now, by the way. If x is equal to 0, y equals 3. And if x equals 3, we put in 3 here, we end up with y equals 1 plus 3, or 4. So here would be 0, 3, and here would be 3, 4, about right here. And it's a dashed line. Okay? And fortunately, the origin is open. So we're going to take y less than 1/3 x plus 3, and we're going to plug in 0, 0. Is 0 less than 1/3 of 0 plus 3? That yields 0 less than 3, and that is a true statement. So the coordinate of the origin worked, and that means everything on the same side of the graph will work, of the dashed line, I should say, will work. And there is the answer for number 24. The answer, of course, is the graph. Okay, well, I only have one more to go here, and I'm just going to give you a little rule. You can discover this by plugging in the origin, of course, on your own. But looking at question number 28, you'll be doing 27. Notice that we've got the graph of y equals minus 3/2 x plus 3. Okay, and I'll actually put that graph up here. It'd be like going to 3 on the y-axis, and then it's got a negative slope. You can think about it as going down 3 and over 2, or up 3 and over 2, your choice, okay? That would be how we get the graph. So that's the first thing that they give us. Okay, now I'd like you to look at 28A. Okay, this was 28, and now I'm going to do 28A off this graph. Now 28A asked us to go backwards. They give us the shading, and the shading, in other words, we already have the graph, and the shading is above or on the right side of that graph. I think the term above is better. And then they want us to name the graph. Well, we haven't been asked to name before, only to draw, and I'll give you a little hint here. You can plug in the 0, 0 and use that method, but if the graph is, if the shaded region is above the line, then it's a greater than. So this would really be y greater than or equal to, since it's solid, minus 3/2 x plus 3. Okay, now let's go look at 28B. Okay, so we still got the y-intercept of 3. We still go down 3 and over 2. Still looks something like this. Okay, but now they have shaded. They've changed the equality. As soon as they shade, it's now an inequality. Okay, and I will just tell you that since the graph lies below, the shading lies below the line, then we can conclude in this situation that the new name of the graph would be y less than or equal to minus 3/2 x plus 3. Okay, and remember the line is, since the line is, the graph itself is solid, that means that it's a less than or equal to. Now if you wanted an extra check on this, you could plug in 0, 0. And of course that would yield a true statement. 0 is indeed less than or equal to 3. So actually on question 27, the one you'll be doing, you should be able to pretty much look at those and once you have the main graph, tell whether it's going to be a greater than or an equal to. Anyway, we still have some more. I think we've got one more application of graphing, quite an interesting one coming up, and I'll be back shortly to talk about it. Thank you.